Hey everyone, it's Kyle with Coding on Chain, and in this stream, Roberto is wrapping up the Dandelion series, this time with Linux. He's also joined by Jaime from Boost Pool, so huge shout out for him for joining. And reminder, if you don't know what Dandelion is, it's a collection of Cardano services that allow developers to get going quickly building on the Cardano blockchain. So head over to dandelion.link to learn more today. If you like this type of content, let us know in the comments, like, subscribe, and if you're an ADA holder, check out our pools Lift, Peace, and Boost. Anyway, let's jump in.
So it seems it's working. I cannot play Twitch here, but we are live.
Okay. Hello, everyone.
Hello everyone, bear with us because I'm having some troubles with OBS. I restore my system. I don't have hardware acceleration, my graphic card, and OBS. And I need to tune the title for this video. And we will be talking about Dandelion. I need to tune up. We will be talking about Dandelion in a minute and deploying on Linux, which will be pretty straightforward. So what I thought to go into details today into the customized Dandelion template, so I can walk Jaime through them and try to explain a bit about what's there and how it works.
That's cool. We can add the repository links to this chat so anyone can go through it.
Yep, good idea. Let me log in on Twitch because probably I'm logged in here. Yes, I am. Okay, so I will change the title from here.
Cool. I've never used KHS to build Adestria or Cardano DB so it's good for me also.
Yeah, you know, Kyle, who is the typical host for Coding on Chain, he had Dandelion, not Dandelion, DB running on AWS, and he was using an external Postgres instance from AWS service, RDS. He was like paying, I think it was €100 just to keep it there online all the time. And now he's using the local DB because it's just cheaper.
Yeah.
Big Com is asking if there is a link. Yeah, let me share with you. This is it.
Cool, perfect.
And I cannot find the theater model on Twitch. And we are streaming with the title from the last week. Oh man. I think I can change that from OBS somehow.
Okay, for now in Twitch the screen is black.
Yeah, that should be my. Can you see something now?
Wait a second because of the delay. No yet. I just can see your pointer, your mouse pointer, but nothing behind.
OBS should be streaming my terminal already. Yep, I can see my terminal, but it's not.
Oh, no. Yeah. No, it's good.
It doesn't fit the screen. Stretch
Yeah.
to screen.
Yeah, that's true. It's like we need to see more in the left. More, yeah.
Wait. Let me reset transform. Now it looks better. Should look better.
Okay, I'm waiting for the delay because for me it's the same. Yeah, now it's better. Yeah.
Okay, I got to
Okay, perfect.
coding on chain video producer, and I think I can change the name of the video here. Nope. This is actually Kyle renaming it every week, and I'm not sure how to do it. So I'm gonna skip that. We will
No problem.
we will do it later when it's finished. So let's focus on what's important here. Deploying customized Dandelion on my local laptop. So this is gonna be really quick. So I already have Docker. I already have all the prerequisites, which are kubectl, customize, and Helm. So I only need to deploy a cluster dedicated to Dandelion testnet, render the template that creates every resource, every YAML manifest that will be applied to the cluster, and then just apply them with, I will be using KApp, because again, it's my favorite for deploying YAML manifest to Kubernetes, at least locally. So yeah, let's start by copy pasting. I mean, I follow this approach on every video, just to try to. I know it kind of feel a bit stupid to do this in 3 different videos, but what I want to highlight is that it doesn't matter if you have developers running on Windows, running on macOS, or on Linux, that you will deploy this thing in the very exact same way. Also in the cloud, you will probably do slightly changes, so you run on every pod from this Kubernetes deploy in a different underlying instance, hardware instance, or virtual machine. So for that, you will like to use Kubernetes affinity and that stuff. And we can probably do another session in the future to actually show how I've handled this on my cloud Kubernetes cluster. But for the moment, let's start copy pasting again. So creating the cluster, it should be quick because I think I already have the images locally in my Docker daemon.
Okay.
Previous to this session, we were talking with Vicente from Emurgo, who started using this deploy to connect to DBSync and stuff. We were debugging some network problems he had, because he wasn't able to access his Linux box from outside. We tried to fix it, but we didn't find the ghost in that in that private network. So yeah, server is done, load balancer is almost done. You can track this is, I mean, in this session that I guess it's for Linux, let's say a bit more advanced users, I want to do some different stuff like checking logs for the load balancer that K3D deploys, which, as you can see, it's an Nginx that will refresh its config file whenever a new service is created, and not a new service is created, but an ingress controller, an ingress object is created in Kubernetes. Sorry, the server, which is actually Kubernetes itself with kubelet and all kube proxy. Oh, all the services that really compose Kubernetes.
Yeah, that's in Jinx, no? Or that's
This is the Kubernetes server, which is the Kubernetes controller and all the services that handle image garbage collection, logs collection, garbage collection, because in Kubernetes by default it will rotate the logs for the pods. I mean, you destroy one pod, and the logs that it produced are like eliminated. Yeah, so there are many different microservices running. I mean, if you do getpods -a, capital A, you get all the containers that run inside the cluster that are part of the control plane of the Kubernetes cluster, like the core DNS server, metric server, yeah, containers that are part of the Kubernetes deploy. But then you have the actual Kubernetes server, and these are the logs for them. So you see that it's continuously complaining about things, doing things in the backend, and those processes doesn't belong to the cluster itself. They are the actual controllers of the cluster.
okay. So they are like external, auxiliar service to you to use with your.
It's
Uh,
it's Kubernetes itself. I mean,
okay, okay, yeah.
if you go for vanilla Kubernetes, you have a bunch of processes built in on that.
Okay.
If you go for K3S, which is what we are using, that's a different flavor, and that implements Kubernetes, that compiles Kubernetes source with some specific capabilities. So
Okay.
you have vanilla Kubernetes, and you have lightweight K3S Kubernetes, which is what we are running. So I will stop this and clear the logs so we are not distracted. Oh, what's happening here? Bots are not scheduling. Uh-oh. Damn it. This is because I don't have too much free space. So this is a cool thing to that happen because we can express how great Kubernetes is. I mean, this binary that it's running on your host system, it checks for the health of the underlying base operating system. So for me, he's checking the free space. It's checking if there is too much. If you do, this is a custom bash function that I have, which shows you the status for the for the nodes in the cluster. So Kubernetes checks if the node has connectivity, if it has enough memory, free memory, if it has enough disk space or enough or an appropriated input-output load in the disk, if there is process identifiers pressure because this is a thing that can happen when you spin like tons of Docker containers. You have many different process IDs on different kernel namespaces. That could be a problem because there is a limit. So whenever a node gets out of some of the resources that Kubernetes check, they should become non-ready. And that's actually what's happening, because this pressure is true. Here it shows it's ready, but then pods are not scheduled to run in this single node because there is this pressure. So let me try and make some space because else we won't be able to deploy anything.
Yeah. So how much space do you need, more or less?
I'm not sure what's the limit that this K3S is checking, but probably you need at least some gigabytes. So it's so the scheduler is happy to pull Docker images and don't fill up the disk, because that will cause interruption on running services. So this is a protection mechanism that operators like me thanked because you don't want to be checking all those things. You probably want to launch pods to a cluster and let the scheduler take care of those things. And if there aren't enough nodes in the cluster, you have typically you have cloud controllers that will spin up new hardware nodes and then schedule there the pods. And you can forget about checking for free space and stuff like that. So
I don't like that. I don't like that task.
there will be a time in the future when operators are not system administrator won't be needed. That's called no ops. For that we need these orchestration frameworks that provide us with automation for tasks that were part of the system administrator, like watching for free space and adding more disk. Well, we now have hypervisors and cloud providers that will give you a new instance and a new disk by a request on an API. So that job is done. DevOps, systems administrator, it's better that you go on looking for some different work, because you have been automated.
Yeah, the machines are coming, and that's the we are forget.
So let me remove this weekend I've been repackaging this Linux kernel, trying to make my new SSD disk to work. It didn't happen, but it took like 25 gigabytes to compile the kernel. Let's clean it up. Hopefully what happens then is that Kubernetes realized that there is no more this pressure. Still. Okay, let's do one thing. Let's delete the cluster and start from the scratch. This is another cool thing that you can do. So it's so easy to start from the scratch that you can just do it. Let's recreate the cluster. I'm not looking at Twitch now. I don't know if there is someone following us and asking questions. I'm gonna put this over here. Oh, thank you, Kyle. Kyle fixed the title.
Perfect.
Bitcom, yes. I've been not repackaging, not only repackaging, I've been trying to patch the PCI Express controller for my kernel because my disk goes into deep power management state, and it won't wake up. So I've added some patches trying to fix it with quirks. Like, quirks are specific patches for a specific hardware drivers that try to work around problems. And yeah, I've been recompiling the kernel to add some quirks for my disk and the controller without lag. So I don't have much more time to work on that, and I will be just ordering a new one, a different brand. Okay, so we deployed the cluster, and now it works. It deployed the control plane down. Okay. Now let's go on with the README. Copy pasting. We've deployed the cluster. We rendered the templates. In this session, I don't know if I already did this, but yeah, let's walk through a bit through the output from customized, which, as I've said before, it includes every resource that will be applied to the cluster. I use config maps to contain like auxiliary scripts, like this one that copy files from my Docker image to the path that GraphQL looks for, the config and the Genesis files. I have the config JSON for my Cardano node. I have another config map for environment variables that I use in the containers. This is a workaround that should be included somewhere else. These are scripts from Postgres high availability chart from Bitnami, which is a company from my from my city, by the way. I don't know if you knew that, Caso, that Bitnami is from Seville.
No, I didn't know.
Seville.
I didn't know.
Yeah, they are pretty big now, but they started like, they were like, I don't know, less than 15 people. So yeah, this is pretty extensive. I mean, they are 2,500 lines that end up with the ingress for the local host endpoints. And that's it. We rendered it. Let's apply it.
And for example, if I want to choose my own ports, because this is some issue is common when you are running this type of service, that you want your own port, because maybe in the default port is already running another thing, no?
Yeah, but in this case, everything you have exposed to your host system. I mean, this is running inside a container, which
Okay.
is running then different C groups. C groups is the mechanism from the kernel that groups processes and jail them and basically containerize them, put some resource limits and separates process namespaces. So inside Docker, we have Kubernetes doing all that containerization. So you can have like thousands of services running on the same ports, but listening on their own network namespace with different private IPs. And that's everything managed by Kubernetes. So you don't worry if let me apply, and I will show you when it's done.
That's cool. But even when you have or your service running, you have to expose to the external internet, to the external world, some specific ports. So
Yeah,
you have
this
you can use the same port for two different servers.
well, actually you do. I mean, we are only exposing from that Docker container running Kubernetes port 80, port 443 for HTTPS, and this is the control plane, which is not even exposing the same port to the outside world. And the way you handle running different services here through HTTPS is with the ingress controller. I mean, HTTP requests include
Okay.
includes every HTTP request includes a host header, and that's what the web servers use to know where they should route the request to.
Okay. I think I got it. Okay.
I will show you. I mean, it's included in the README. It's the way I
Yeah.
say, okay, let's query GraphQL API testnet local. And I include that as host header. And then I just target localhost 443. And behind that port, there are Postgres API, there is GraphQL API, there is Submit API, everything listening on the same port because it's the web server, which is
Okay. I didn't know that. Okay. Now,
yeah.
thanks for me. Okay.
That's the way it does it.
Okay.
I think we have some problems with Postgres, with Nami Postgres. Oh. No, it's so it's saying that no, it's pulling the image. Okay, so it was just a temporary message, temporary error. So with -A, you list every pod in every different namespace. With -N namespace, you get only those running on this namespace.
Okay. That's cool. Okay.
This is taking longer here than in my Windows tablet. But it will eventually it will reach an unstable state. So what else I wanted to say about how Kubernetes or
Well,
yeah, please tell me.
okay. I would like to see maybe when the service is full running, just query, just querying some service, and I would like to know how perform that command to HTTP.
Okay, so let's watch this here. Meanwhile, I'm gonna show you how you run GraphQL. I mean, how this works. You run a container inside a pod, which listens this specific port, and you can have like many different containers listening on the same port because the way I told you, Kubernetes containerize the network space for these containers, so there is no collision on port listening. Then you have the service, which is another Kubernetes abstraction that selects containers running on pods by labels and
Okay.
target different ports. I don't know. Imagine that you have on GraphQL you have two containers on this pod. Both of them listen on a different port. So you target the port with the selector, and then target the specific port. For GraphQL, it's this one, but say you have GraphQL extended and it's listening here, but it's inside the same port. You target it, and well, it will be. I think this one, I never remember it. This one is the port you target, and this one is the port the port where this service will listen.
Okay. It's the port where you will perform the HTTP request.
Right, where the ingress will forward. So if you do this again, now we have many different ports, and we can see that GraphQL will listen the service. Okay, this is service. The service will listen in the same port than the container, but this is something you can change. I don't have good reasons to do so, but you can do it, because as you can see, every pod, every service will listen on a different IP, so you could have different services running on this port. It's no problem. Actually, you can see here that you have a headless, which means that it doesn't have a cluster IP, and I won't go deep into Kubernetes networking, but I hope this gives you a hint on how it works, more or less. Okay, so now this is running. It took like 5 minutes. It was okay, and there are some pods that got some restarts until for example, Hasura will try to connect to Postgres. And this PG Postgres pool, it's a service for load balancing Postgres queries, and will fail if Postgres is not up. I mean, the backend Postgres instance is not up, so it retries until it connects. And Hasura does the same with the PG pool, and it restarted 3 times. But the good thing is that you don't need to wait and do these restarts manually. The way Kubernetes will orchestrate these pods automatically provides you of resilience and reliability. So Bitcom has some never mind, you answered my question. Okay. So yeah, I wanted to highlight why the pods restart until they become running and stable. We don't have to do anything about it. So, answering to your question, let's query the GraphQL endpoint.
Okay, cool.
Okay, this means that GraphQL. No, wait. This means that I need to remove this header, and I need to fix. GraphQL is still not ready. It's returning some error. I usually. Okay, this happens because dbsync is not ready.
Yeah, because dbsync require more time to get up, or is
Yeah, you need Cardano node to sync the chain. Then you see here that it has Cardano dbsync had some problem connecting to. No, it didn't have any problem connecting to the Cardano node socket, but yeah, it will take some time. Need to start syncing, and then GraphQL is able to perform its schema apply, and that's it. Here it is. Now it's working. Okay.
Cool.
So yeah, it was waiting for Cardano dbsync to apply the DB schemas for GraphQL, until it did retry. It was failing. Now it managed to insert the query, the schema, and it works. So what happened when we actually requested to localhost, which I remind you that this is Docker listening on this 80 and 443 port. We requested that Docker tunneled that connection to the Nginx server running on this container, and I think I had that here, not this one. Server load balancer. So there is no logs here, but it's this Nginx who is receiving the connection.
Cool.
And then it's forwarding the connection to the ingress, to the ingress controller for the system, which is traffic. And I think this by default did not store logs. Let's check. Cube system. Okay, we can change that. So even though we don't see any logs, what's happening is this Docker container which runs Nginx is forwarding the connections to this traffic container, which ends up forwarding the connection to the appropriate service based on the host header.
Okay.
That's the way it does it. We can do this. And I think GraphQL now doesn't, yeah. As you can see, if I what's happening here? No, it doesn't. GraphQL won't log any request neither. So it's disk space savvy. But we can, let me, no, not this one. Cube config. And this cluster that I'm preparing for new Dandelion using latest DBSync and GraphQL version, I ran K3D on a different provider, which is Contabo, and I tweaked the traffic, so there are some logs. Let me do the same with our local deployment, if it works. Oh, yeah, I need to. Well, let's do it live, so I don't copy. Let's do it from here. It's easier. So let's modify traffic config map.
Okay. You set the logs, no? You just set the logs. Okay, cool.
Yeah. And I mean, I have that somewhere else, so I don't have to Google for it, but I think I will find it easily. Yeah. Oh, not that is silly, maybe. Well, let me try. So as you can see, traffic uses the same approach. You have a config map where the config file resides, and this piece of the YAML will be mounted as a file inside the traffic container. And you can do things like this. You edit the config map, and in an ideal world, you will be doing this through a commit, following a GitOps approach. So every configuration needs a version, but we will do it wildly. So you edit the config map. It's taking some time. I don't know why. Hello, computer. Oh, no. Okay. And then if we are fast enough, we will see that traffic did not restart. So if we delete the pod, given that this is a deployment, a Kubernetes deployment, which is another abstraction, the scheduler says, okay, this pod has died, has been deleted, but I need to keep one copy of it running. So you delete it, and the scheduler automatically launch a new one. Yep.
Yeah, and launch the new one with the new configuration because you changed it.
Yep.
Okay.
So let me get the let me save the kubeconfig. I prefer to work with kubeconfig files than with context for Kubernetes. So this is the authorization. Let's say Dandelion testnet YAML, and I point to that file, and I get pods, and now I'm connected to my local cluster. Okay, so now logs for this traffic should at least show 200 responses. So if we curl GraphQL, we get entries for traffic, and they are JSON. So we could do something like, oh, I'm missing JQ. How can that be? So whenever we query the local GraphQL, now traffic logs all this: backend name, scheme, the internal IP for the service.
Okay.
Okay, so for GraphQL, this is the backend service. It's not using the, well, this is where Kubernetes networking becomes weird. I think this is the pod, the IP pod for the pod, I mean. And this is the client address, which is the IP for the Nginx container, because it's not forwarding my local IP, which will be a typical 192.168, blah, blah, blah. Yeah, so
I didn't know that you could create your own network, whatever you want. I mean, yeah, whatever
I mean,
the IP.
curl is using my local private network for my base system, but given that you are connecting to a local host, your IP should will be like local host, and that's for Docker proxy, which is the process that listens here in those exposed ports and forwards the connection. So traffic has no way to know which is my external IP here.
Oh, okay.
And for it, it's an internal IP from Docker daemon, which is used. And all this routing is done with IP tables. That's it. In the cloud environment, you probably have the load balancer listening on a public IP, and then clients connect with the public IP, and then if you have different layers of routing, let's say you have traffic as ingress controller, but then you have an nginx that is in front of your GraphQL, because with that nginx you do whatever redirects, some request transformation, which are things that you can do with Conf, which is a service that we will be including in Dandelion soon. Yeah, and those HTTP services, traffic, will include a header, a HTTP header saying, okay, I'm forwarding this request from this real IP. And then the following web server, nginx, will say, okay, I grab those and I will include that I'm listening on this private IP, and I concatenate that IP to the X forwarded for header, and so on and so forth. That's the way that you forward real external IPs.
Okay.
But just to let everybody knows, I'm not logging any public IP on Dandelion deployments, because I have no intention to do any analytics on that side. I'm all in for privacy. I don't mind anyone's IP.
Yeah,
So
yeah. But could be easy to integrate it if someone want to integrate some type of analytics.
yeah, I mean, you need
Yeah.
to enable on traffic the forwarding of this real IP, and you need, if you have extra layers, you need to configure them to perform the forward of this header. But
Okay.
yeah, it's completely possible, but will vary,
Yeah.
will differ from deploy to deployment.
Yeah.
So I'm not sure if I want to tell anything else here. I mean, I could bloat my laptop and try a mainnet deployment, but we did that on macOS session, so we already showed that it's possible in the same way that we do it with testnet. We just change the variable to say mainnet. Yeah, the other thing I wanted is to walk through the actual customized templates. Let me share a different screen for that. Oh, Caso,
Yeah.
you've been replaced by some GitHub window. Do you remember the other
Ah,
day
yeah, yeah, yeah. True. Yeah, yeah.
OBS keep swapping windows. This time it's your face.
No problem. It's more pretty. Yeah.
Let me fix it anyway. Where are you? Oh yeah, I know why it stopped working. Problem was obviously between the chair and the keyboard. You are back.
Oh, yeah.
Okay, so this is the traffic web page where I got the
Traffic.
access.
Yeah.
Yeah.
I I
It's a
didn't know before. That's
it's
cool.
a it's a typical lightweight web server that will perform let's encrypt certificates rotation for you. Yeah, many things. I mean, it's today it's a really complete web server. It's really cool. Easy to configure. Friendlier with these toml files. It's cool. So the only thing I change is for our Kubernetes pod is instead of using a log file, I replace it to use dev std out, which is what a Kubernetes gets from the container. I mean, it's what you use for containers to log things, standard output. Okay, so back to customize Dandelion. I think I can go through base. Is the basic. These are the all the services we run. We have Postgres coming from Vietnamese Helm chart. Helm is another Kubernetes templates package system. There is a lot of software distributed in this way, and this is the chart I'm using. I cloned it here. I could have used a git submodule, but I didn't want to deal with that, so I just cloned it here. They are basically YAML files in the same way that customize. You have this way of splitting Kubernetes resources, but then you'll find these templating annotations, which provides you with loops, some encoding capabilities. Yeah, whether you like it or not, it's the standard for distributing Kubernetes templates. I went customized because sometimes you need to modify the Helm charts. You don't find in the values in the input variables they handle. You don't find what you need to modify to patch, because yeah, this is well structured and it abstracts you from actual Kubernetes resources. You have things like service account enable or false, and then the template will render whatever this means. But sometimes these values doesn't provide to you with all the flexibility you want, so you end up using customized like this with chart inflator generator, which takes a directory with a Helm chart. You need to specify the name. You need to specify a release, which is another abstraction for Helm, and a values file. And then you can apply to these resources that are rendered some other patches that allows you to customize anything on the Helm chart. This was an external plugin. It was built in Bash. I contributed to that plugin in the early days of Customize. which is a project from Google itself. And then they decided to include it on Customize, and it's now a built-in plugin. So that's one thing I wanted to tell about Helm charts and Customize. And then, yeah, these are our independent customizations for every service we run. For DBSync, you have customization, which is based on these free resources. And you go here, and what you find is what we saw before in the output.html YAML. You have the stateful set. I won't go into details on what a stateful set is and why it's different for deployment, which is another Kubernetes kind. I will just say this is what you want to use when containers keep state on local files. Yeah, you have containers, you have its environment, you have volumes that you want to mount. I use Node IPC to mount the socket, and I do it in a hacky way. This is another container running along with DBSync in the same pod, and what it does is connects to a TCP port where a Cardano socket, where Cardano node is listening, not Cardano node, but another SOCAT instance is listening on TCP. You know that you cannot connect to Cardano node via from a remote machine. So I hacked that and used SOCAT to listen in a port, and then I listen in a socket, and I forward everything that comes from this port to or inbound or outbound. I forward it to this socket file where DBSync connects. And the other side of this thing, it's Cardano node, stateful set. You have Cardano node, obviously, and you have the SOCAT TCP server, which do the reverse. It connects to the Cardano node socket and listen to the port. So this is a tricky, hacky thing I did. And I also have Chisel, where I was mentioning to the other day, which I use it to basically transport this TCP port, which has no security. I mean, this is plain TCP. You forward raw bytes from the TCP port to the socket. But what if you want to transport that over the internet? You ideally want it to be transported through HTTPS or at least some security layer. That's what you could use Chisel for. It's basically a TCP tunneler, TCP over HTTPS tunneler. You can tell Chisel, okay, connect to this, and whatever you get into this port, encrypted with SSL, you will forward it to here. But I'm not really using it. I mean, I tried it, it worked, so I can transport this socket to my local machine from a remote environment, so I can perform some debug. But this is the coming soon that you will see on Gimbal Labs website for the Node socket service. But it's not enabled. I mean, support is there, but it's not something you can really use unless you want to play with it. It's there. Now you know the trick. Feel free. And yeah, then we showed Cardano node, we showed Cardano DBSync, the Helm chart, and then we have basically the same for Rosetta, Submit API, Ogmios, Postgres. It's essentially the same. You have customization, which includes at least deployment stateful set, a service, which is the internal service to the cluster. A common environment for all of them. And the way you take that base, which has some predefined Docker images and some predefined environment variables that you might want to make more secure, not make one, but you want to make more secure than change me, for example, for a password, then you have overlays. There you basically do another customization, which includes every base and add some more resources and add some patches that are applied by selecting kinds and names. This is the way I patch, for example, the dbsync image for testnet and for mainnet, the size of the physical volume claims, which are the disks that are bound to or mounted into pods. Yeah, let's see some of those, because it's interesting how you patch things. Yeah, you can patch by replacing YAML paths. This is a patch for the image, and you can add values to the YAML path, and you can delete also. You can add, replace, delete, and I don't know if I miss something. But yeah,
I have a question. Sorry,
sure.
Roberto.
Please go.
Okay, so if, for example, today I set up this Dandelion, and tomorrow or next week, for example, the Cardano Node version it's upgraded, how can I just change that version and
Okay,
not without change the other service?
Cool. So we have this patch, and you can see that it's using my Docker images, which I build as they are released. I use Hydra binaries. I mean, Hydra is the CI system from IOHK. It has every commit that has been push it to the Git repository. It's built and it's evaluated using NixOS, and you can use those. You can use those evaluations from NixOS to grab new binaries. So
Okay.
instead of compiling, I'm trusting Hydra for the binary artifacts. If this system is hacked or tainted, this artifact shouldn't match the checksum. Okay, so you have a way to check that everything is fine. And these are the binaries. Okay.
I didn't know nothing about this. About this. That's good.
I know some shortcuts. I take all of them. So this is where the binary builds come from. It's from this branch, and you can see that in actions. I build this publicly on GitHub Actions.
So you can even, maybe this is just for stateful operators, you can even copy that binary without compiling nothing.
Yeah, I mean, what you find here, it's binaries, statically linked binaries. So you don't have external depends on libraries on your underlying operating system. So it's fine to use them. You also have, not only for Linux, you have for macOS, Windows. Yeah, this is their official Docker image artifact, and you have binaries separated.
Before, before when I wanted to use, I don't know, for some example, for other reason, to get some binary, for example, Cardano node or Cardano client, I always went to my Sun Relay and copy paste that binary and, yeah, and take it to my local machine or wherever I want. But now that I know this is possible, this is
Well,
good.
yeah, and my images is what I use for Dandelion. It's a very opinionated way to build the images. I ran the entry point for them are uh, these wait are these functions that I cooked myself, where
Mm.
I establish some environment and then just run as leader or run as passive. Docker image for, as you can see here, this is IOHK testnet passive mode, so I don't need to deal with commands and arguments inside the Kubernetes. I know the entry point for this image is already for testnet passive. Um, you know, it's my flavor. But yeah, back to your question, how you change this is here, but you
Okay.
you need to take into account that if you change it for your own Docker image, you obviously need to go through the base Cardano node
Yeah.
stateful set and say, okay, this is, well, I have here some specific entry point, but you don't really need to do this. It should start, but yeah, you need to match the environment to your Docker image and yeah,
Yeah.
make it work in the same way. So if you don't want to, you know that I'm building those for you. If you trust me as I won't, include any Trojan, but if you want to make sure that that's the case, you can see that this GitHub action is who built the image and pushed it to the registry, and you can check the hash for the image is the same that it's in the Docker Hub, so you can verify. You don't need to trust me if you want to use my
Yeah.
images. Okay,
That's the
so
way. That's the way.
I don't hide. That's what I'm doing this session for advanced users on Linux, because yeah, it's cool to tell those things. Um, okay. So, do you have any other question?
I think no, because okay, I'm learned how well. So you teach us how to set up your Dandelion service that in the final stage is Adrestia, no, because
Mhm.
it's the set of all the service behind Cardano. And after that, you show us how to perform request query. So I think, yeah, that's the end-to-end test. And also you show us how to change configurations. So yeah,
Um,
that's cool.
I'm not sure how much time this was sharing the wrong screen. I just realized it was sharing a different browser without me even
No, no, no.
even
What was okay? I think there's.
okay, because when I checked OBS, I was seeing again an API auth mechanism thing like in the previous session. That was this diagram popping up from time to time, even if I didn't change anything on OBS. But okay, if you
Yeah, yeah. On Twitch was okay. No
perfect,
problem.
perfect. So I think we can call this a session. I don't know if the guys in the chat
Let me
want to.
know. Let me check it. No.
And by the way, Kyle, if you are listening to us, you could add to the title that we went a bit deeper on the Dandelion templates. I don't know. We can do that later, but
Okay, that's cool. That's cool. Thank you, Roberto.
thank you, everybody.
Wonderful.
Let's go on hacking. Bye bye, guys.
Bye bye.
Okay, if I can find OBS, stop streaming in 3, 2, 1.